Everyone wants a crystal ball. It's this universal human desire, isn't it?
Oh, absolutely.
Whether you're a day trader, a central banker, or just, wondering if you should lock in a mortgage rate, we are obsessed with what happens next.
It's basically a survival instinct.
Yeah.
Especially in the financial world.
Yeah.
If you aren't trying to predict the future, you're already history.
Yeah.
But here's the reality check, right? Most people are just terrible at it.
Right. We all remember the one person who predicted the 2008 crash, but we forget the 10,000 who predicted a crash every single year that never happened.
Exactly. And that brings us to the stack of research we're diving into today. We're looking at how the pros try to move from just guessing to actual forecasting.
Mm-hmm.
We're stripping back the layers on time series analysis and looking at a specific piece of software that's become a standard for this. EViews.
EViews. Okay, the name sounds a bit dated, I'll admit, but digging into these sources, this tool is an absolute beast.
It really is.
It's what econometrics students agonize over and what Wall Street analysts swear by. So our mission today is to figure out why. How do we take this messy pile of historical data and turn it into a reliable roadmap for the future?
And I think we should manage expectations right out of the gate.
Please.
We are not teaching magic here. EViews doesn't spit out lottery numbers.
Mm-hmm.
This is all about statistical rigor. It's about finding the signal, the mathematical truth that's hidden inside a whole lot of noise.
So less magic spell, more advanced math. I can get behind that. Let's start with the core concept then. The sources keep hammering this term, time series analysis. Now, I know what a time series is. It's just data over time. But why does it get its own special branch of statistics? Why can't I just use a standard regression like I would for a normal science experiment?
That is the million-dollar question.
Yeah.
And it's a great one. Standard statistics, usually assumes that your data points are independent.
Right.
If we survey 100 people about their favorite ice cream, person A's answer doesn't really affect person B's answer.
They're separate events, random sampling.
But in a time series, the order is everything. Today's stock price is heavily influenced by yesterday's stock price. This year's GDP is built on last year's GDP.
Temporal dependence.
Exactly. If you treat that kind of data like regular data, if you just shuffle the order, you destroy all the information. It's like trying to analyze a movie by looking at a pile of cut-up film frames.
You lose the plot. That's a great analogy.
You lose the entire plot.
So time series analysis is about understanding the sequence, the narrative of the data.
Precisely.
Yeah.
And the applications are just massive. In economics, you're forecasting GDP, inflation, unemployment. In finance, it's even faster. Stock trends, interest rates, currencies.
And the stakes couldn't be higher. This isn't just about passing a college class.
Not at all.
If a central bank gets the inflation data wrong, they could trigger a recession. A hedge fund ignores these patterns, they blow up their entire portfolio.
You are flying blind, and billions are on the line. But, getting to that level of accuracy is not easy. The source material we have highlights some common student challenges. There's a steep learning curve here.
Yeah, the sources mention that students often feel like they're just drowning in the math.
They are. The barrier to entry is high. They struggle with the complex concepts, which we'll get into, but also just selecting the right model. There isn't one forecast button.
And before you even get to the models, there's the data itself. Data cleaning sounds like a chore, but the sources say it's where most projects fail.
It is. Real-world data is a mess. It's missing values, it's formatted weirdly. If you jam that messy data into a sophisticated model, you just get garbage results.
Garbage in, garbage out.
That's the mantra.
So it's a minefield. Okay, before we get into EViews itself, I want to tackle the jargon. Our sources threw a lot of terms at us. Stationarity, autocorrelation, ARIMA. I feel like we need a glossary.
Let's do it. This is the vocabulary of prediction. You have to speak the language to use the tool.
Okay, let's start with the big one. Stationarity. The source says this is vital. What does it mean for data to be stationary?
Okay, so imagine you're trying to predict the location of a drunk person walking a dog in a giant open field.
I'm listening. This sounds familiar.
If they're just wandering aimlessly, right, that's a random walk. Their average location is constantly changing. The variance, how far they roam, is always expanding. You can't predict where they'll be in an hour.
Because there's no anchor.
There's no anchor. That is non-stationary.
Okay, so non-stationary means the fundamental rules of the data are shifting while you're watching.
Exactly. Now, imagine that same person is on a leash attached to a pole.
Okay.
They can stumble around, but the leash always pulls them back toward the pole. Their average location is the pole. The variance is limited by the leash. That is stationary.
And we need that pull. We need the anchor to make a prediction.
We absolutely need it. Most raw economic data like GDP, stock prices, it's the drunk guy in the field. It trends upward forever. It's non-stationary.
And if you run a standard analysis on that,
Garbage. You get what we call spurious regression. You might find that U.S. GDP correlates perfectly with, say, the number of skyscrapers in Dubai, just because both are going up over time.
it's a false relationship.
Completely false.
So how do we put the data on a leash?
We use a little trick called differencing. Instead of looking at the price of Apple stock, we look at the daily change in the price, the return. That return usually bounces around 0, sometimes up 1%, sometimes down 1%. It's stationary. We can model the change even if we can't model the level.
That is such a crucial distinction. Okay, that makes sense. So what about trend versus seasonality? I feel like I know what a trend is.
I'm sure you do. A trend is just the long-term direction. Is the data generally going up or down over a long period? Think of the stock market over 50 years. The trend is up despite all the crashes.
And seasonality,
That's the periodic fluctuations, patterns that repeat at specific intervals.
like retail sales.
The perfect example, they always spike in December. That's not a trend. That's seasonality. It happens every year.
So your model needs to know not to panic when it sees a huge sales spike in December. It needs to think, oh, right, it's just Christmas.
Spot on. And a tool like EViews is great at deseasonalizing. Data stripping out that Christmas rhythm so you can see the real trend underneath.
Okay, trend is the direction, seasonality is the rhythm. Got it. Last vocabulary term, autocorrelation.
This is the heartbeat of time series. It's just measuring the correlation of a time series with its own past values. It's asking, does what happened yesterday predict what happens today?
Give me an example.
Temperature. If it's hot today, it's highly likely to be hot tomorrow. The temperature today is autocorrelated with the temperature yesterday.
Okay.
In finance, we look for these links to see if past prices influence future prices. If there's no autocorrelation, you can't forecast. It's just a coin flip.
So if we find these patterns, the trend, the rhythm, the autocorrelation, we can build a model. And the source lists this alphabet soup of models, ARMA and ARIMA. Can you decode these?
Yeah, let's break them down. These are the engines. First, you have AR, that's autoregressive. These models use past values to predict future values. It's basically saying, because inflation was high last month, it will probably be high this month. It relies on momentum.
Straightforward. What about MA?
MA is moving average. This one's a little more subtle. These models use past forecast errors to make their predictions.
Wait, they use the errors. How does that work?
Yeah. It looks at the shock. Think of it like a shock absorber. If there was a sudden, unexpected spike in oil prices, an error in your last forecast, an MA model helps smooth that shock out over time.
Interesting. So AR looks at momentum, MA looks at shocks. And I assume Airman just mashes them together.
It's the heavy hitter. ARIMA stands for Autoregressive Integrated Moving Average. It combines the AR part, the MA part, and adds the integrated part, which is just the difference thing we talked about.
Putting the data on the leash.
You got it. So ARIMA is a model that handles the trend by differencing and then uses past values and past errors to forecast the movement. It's the Swiss Army knife.
I can see why students struggle. That is a lot to keep straight. And this is where EViews comes in.
This is exactly where it comes in.
The source calls it a comprehensive statistical package, but why this tool? Why not just Excel? Or, for the data nerds, why not Python or R?
Well, Excel is great, but not for this. It just doesn't have the built-in statistical tests. You'd have to program the math yourself, which is a recipe for disaster.
Okay.
Now, Python and R are incredibly powerful, but they're code-heavy. You spend 80% of your time writing code, debugging syntax, and only 20% actually analyzing the economics.
And EViews flips that ratio.
It flips the ratio. It's a GI-based to a graphical user interface. It's designed specifically for this kind of workflow. So first big feature, data import. You can pull data from Excel, from databases, from online sources seamlessly. No hours of copy pasting.
And once the data's in, you need to see it. The source mentions graphical visualization.
You have to. You can't just stare at a column of numbers and see a seasonal pattern. EViews lets you instantly plot the data, see the trends, see the spikes.
But the killer feature, the reason it's in every university, seems to be the built-in testing, like the unit root testing.
Yes. Remember our drunk guy in the leash?
Stationarity.
You can't just eyeball it and say, yeah, it looks stationary. You need a mathematical proof. EViews has the augmented Dickey-Fuller test, the ADF test, built right in.
The ADF test. Sounds intense.
It's just a rigorous test that gives you a definitive answer. Is this data stationary, or do I need to fix it? Having that built in forces you to check your foundations before you build the house.
The tool enforces the discipline.
Exactly. It guides you through the whole process, making these complex ARIMA models accessible. You're freed up to think about the economics, not the syntax.
Okay, let's make this real. The source gives a practical example. For putting GDP, walk me through it. I'm a student with my laptop open. What's step one?
Step one is visual inspection. You import, say, the last 20 years of GDP data. First thing you do is plot it. You just look at the line. Is it going up?
Okay, I see the line. It's a mountain climbing up. Definitely not flat.
Right. So step two is testing. You can't just trust your eyes. You run a unit root test, like the ADF test. You're mathematically checking for stationarity. And for GDP, it will almost certainly fail. It will say, no, this is a random walk.
So the test tells me I need to fix it. What's next?
You difference the data. In EViews, it's often just a checkbox. Now, instead of a mountain, your plot looks more like a heartbeat oscillating around zero. Now it's stationary.
Okay, we've prepped the ingredients. Now we cook.
Step three is modeling. You estimate an ARIMA model. EViews lets you try different combinations of the AR and MA terms to see which one fits the historical data best.
How do you know which one is the best?
EViews gives you a score, usually something called the Akaikaike Information Criterion, or AIC. Think of it like a golf score, lower is better.
Yeah.
You want the model with the lowest AIC.
Got it. Find the lowest score, lock in the model, and then the magic moment.
Step four, forecasting. You hit the button, and EViews generates the future GDP forecast. It extends that line out into the unknown.
But we're not done, right? We don't just take that number and run to the bank.
Absolutely not. Step five is validation.
Yeah.
You have to interpret the results. EViews gives you what's called a fan chart. It shows the central prediction, but also the confidence intervals around it. It's saying GDP will likely be here, but it could be as high as X or as low as Y.
The cone of uncertainty.
Precisely. You have to look at that cone and ask, does this make sense? Is the margin of error huge? If that cone is wide enough to drive a truck through, your model is useless.
I love that. The human element comes back in. But things can still go wrong. Our expert source warns about common student mistakes. What are the traps?
Even a good tool can't prevent user error.
Yeah.
The first big one is misinterpreting p-values.
P-values. I remember those from stats class. Vaguely. Remind us.
A p-value tells you the probability that your result is just random luck. You want a low p-value, usually under 0.05. It means there's less than a 5% chance this is a fluke.
Okay.
Students often see a high p-value, say 0.50, and think, great, 50% chance I'm right.
Which is not right.
It's completely wrong. A high p-value means your variable is just noise. It's statistically insignificant. You should throw it out. Otherwise, you're polluting your model with junk.
That is a dangerous misunderstanding. What's the second mistake?
It's one we've talked about a lot. Ignoring stationarity. If you skip that ADF test because you're in a rush, your forecast is just, it's unreliable. It's building a skyscraper on quicksand.
It's going to collapse. And the third mistake.
Poor data cleaning. The unsexy but most important part.
Garbage in, garbage out.
That's it. If your historical data has a typo, EViews will still run the numbers. It doesn't know you made a mistake. It'll just give you a crazy forecast.
The software is obedient, not smart.
That's a perfect way to put it. It assumes you know what you're doing.
So, zooming out, for the listener who isn't a PhD student, why does all this matter to them?
Because we live in a world of time series data. If you want to understand why gas prices are up or where the housing market is going, you have to understand trend, seasonality, momentum. EViews and the concepts behind it give you a framework to filter out the noise.
So it stops you from overreacting to every little blip on the news.
Exactly. It's about not getting fooled by randomness. It empowers you to intelligently estimate the future instead of just guessing.
And for anyone who wants to get their hands dirty, the call to action is pretty clear.
Don't just read about it. Practice. Get a trial version of EViews, download some data, any data, and try to model it. Experiment. See what happens when you don't clean the data.
Break the model on purpose.
Yes. Watch it fail. See what happens when you ignore stationarity. That hands-on experimentation is the only way to really learn.
I want to leave our listener with one final thought from the sources that really struck me. We've spent all this time talking about the software, the math, but at the end of the day, EViews is just a calculator. A very, very fancy one.
It is. It can crunch the numbers in a millisecond. It can generate beautiful charts. But it cannot tell you why the data matters.
Right. It can tell you GDP is projected to go up, but it can't tell you if that's because of a new policy, a tech boom, or a post-pandemic recovery.
Exactly. That part requires the human element. The software gives you the what, but the why, the economic intuition, the questioning of assumptions, that has to come from you.
The tool makes you powerful, but only your critical thinking makes you accurate.
Thanks, Ed.
A great reminder that we aren't being replaced by algorithms just yet. We still need to drive the car. Thank you so much for walking us through this.
My pleasure.
And to you, thanks for joining us. Go find some data, check your stationarity, and maybe, just maybe, you can predict what happens next. See you on the next deep dive.